test. Okay, I test. Done. Is this okay? Okay. was with us yesterday, thank you for coming on the second day of our event. Okay, some important reminders. Kindly turn your cell phones into silent mode or vibrate it to not disturb our speakers while they're presenting. The lunch today, for those of you who just came in today, the lunch is at the ground floor, Olive Restaurant. We ran out of badges. So those of you who registered today, you have your name card, the sticker. You just present that and inform them that you are part of the Rainier events, then they will let you in. Okay, so for our first speaker, we have a technical presentation titled Active and Intelligent Packaging to Increase the Safety and Storage Life of Food. We welcome Dr. Nughara E. Suyatma from IPB University and CFAS Center. Let's all please welcome Dr. Nughara. Sorry, mispronounce your name. Yes.
Okay, very good morning, everyone. So, first of all, I'd like to thank you for coming and this for India event for allowing me to present here. So, I'm Nugraha from IPB University. Here in the session, I would like to talk to present about the application active and intelligent packaging. Maybe this is not a new thing, but when I make a survey in the application in the market, sometimes many products still not appropriate in using the type of active and also maybe the choice of the packaging material, etc. Maybe so. I think this is.
Microphone, sorry.
Sorry. Okay. Thank you. So I'll just move to the presentation. So I have divided my presentation into three subtopics here. So first, I will make a short brief introduction to maybe to give you a small just brief explanation concerning the smart packaging that may be also make confusing. What is different smart packaging, intelligent packaging, and active packaging? And the second, I will continue for the active packaging, and finally I will talk for the intelligent packaging to show you the potential of application of intelligent packaging. function on the protection. Yeah. So sorry. Okay. So here, when passive packaging only protect from the external factor, yeah, active packaging can give more function. For example, for oxygen, yeah, we can give with the active packaging to absorb the oxygen, so avoid the oxidation reaction, yeah, avoid the color discolorization, or avoid the nutrition loss, yeah, because oxidation of nutrition sometimes also decrease the vitamin, yeah, for example, yeah. So protection by using oxygen scavenger or oxygen absorber sometimes, but maybe in terms of scientific, scavenger and absorber is very different. Yeah. Why? Because absorber is just physical mode. Yeah, physical mode just by absorb. Yeah, it's physical. But scavenger and scientifically based, this is chemically reaction. So by using change from oxygen into other substance. For example, for this maybe later we will discuss more detail in the next slide. Yeah. And so this is just review opportunity. By using anti-packaging, we can do more than passively as a barrier for external factor. But here, by active packaging, we can also give some substances that benefit. Yeah, for example, we can release antioxidant into the packaging. We can release antimicrobial, or absorb scavenging to eliminate oxygen from the inside packaging. And for communication, yeah, this is function of intelligent packaging, mainly give the communication, because maybe later we'll give more detail in the explanation intelligent packaging. And for convenience, yeah, both active and intelligent can do. So this is different between passive versus smart packaging. Yeah. So smart packaging gives more function, more activity that not only protect from the external factor. Okay, so let's move to the main topic, active packaging. So talking about active packaging, here by definition, yeah, from EU, yeah, I take here packaging that is designed to intentionally incorporate active compounds. So we add active compounds, yeah, that can release or absorb substances into or from the packaging. So, and according to the IFT, active packaging employ technology that intentionally release or absorb. The release means absorb or scavenging the substances that not that maybe have a bad impact to the food. Yeah. Okay. Next. Okay, so here we can see more detail here concerning the principal active packaging system, absorbing scavenging system, but normally is different. Maybe for moisture, we can say moisture absorber, because just only physically absorb into the matrix of silicon dioxide, for example. But for scavenging, needs change of the chemical substances. So spoilage bacteria, the spoilage microbial that spoil the food is aerobic bacteria. So means need oxygen to grow. Yeah. So when we remove oxygen, so the aerobic bacteria will can be inhibit the growth. Yeah. Okay, and the rate of respiration, this is for fresh fruit. Yeah. So when we learn concerning the biosynthesis of the ethylene, yeah, normally the ethylene production in the fruit, vegetable also need oxygen. So when the oxygen is limited, the synthesis of ethylene also can be stopped. So this is why many producers have developed oxygen scavenger. So here is the active material for oxygen scavenger, and we have to precise here there are that moisture dependent and maybe without not yet, so non-moisture dependent. So for the iron and enzymatic activity for the mechanism of oxygen scavenger, this is moisture dependent. So this it means this oxygen scavenger can active when water is available in the system, in the packaging. So this is just applicable for food with high moisture. Yeah, so enough moisture, normally more than 0.7 of water activity. Maybe you learn water activity is free water, yeah, free water and containing in the food, called water activity. Yeah. So when the free water or water activity is more than 0.7, we can use iron base or enzyme base for oxygen scavenger. But for the dried food, yeah, for example snack, yeah, or fried cassava or maybe potato chip, yeah, crackers, etc. So mostly snack is a kind of dried food or fried food. So we have to use that without need of moisture. So we can use the ascorbic acid or yeast and also PUFA. PUFA means polyunsaturated fatty acid, so such as linoleic or linolenic acid. Yeah. So this is or some combination sometimes. Yeah. So this is must be take a precaution in choosing the oxygen scavenger to be effective and to preserve our product. But unfortunately in Indonesia, almost all I have checked one by one. This material almost all is iron based. So normally in Indonesia, the activity of oxygen scavenger just appropriate for moisture food or maybe semi-moisture food. They call IMF, intermediate moisture food. Yeah. More than our wet food. Yeah. For the dried food, normally we have to choose for PUFA or yeast. Yeah. So we have to make sure before using the oxygen scavenger. So what is the substance? So this is the first mistake that mostly encounter in using oxygen scavenger. So by using the type is not appropriate. It's not suitable for the product. And here an example. Normally one producer produce or develop several type of oxygen scavenger. Here Freshpack, they release type of P, D, R and M. So you can see here P means for the moist or semi-moist food, and water activity more than 0.7, and try for dried food, R for the chilling or refrigerated food, and M means for the MAP, so the modified atmosphere packaging that combined with carbon dioxide releaser. Okay, and the second mistake sometimes is the calculation. What is the capacity of oxygen scavenger? Maybe the big packaging, but the very choose good oxygen barrier. Why? If we use oxygen barrier very low oxygen barrier, for example, very high permeability of oxygen. So I think we need very big quantity of oxygen scavenger. And the third, we have to calculate the oxygen scavenger capacity that we need to our product. So how to calculate? Maybe in the next slide I will show you shortly. So and on the right here, I present the three mistakes that some I think often encountered in the application of oxygen scavenger. The oxygen scavenger type is not appropriate, as I mentioned. And in Indonesia, just iron base that available, but so sometimes used in the snack. So I think it's not good. And oxygen capacity is not enough. Very big volume of packaging, but only use very small quantity of oxygen scavenger. And also using the low oxygen barrier, for example, by using the polypropylene. I think mostly snack or traditional or small scale industry use polypropylene. So polypropylene is very high permeability of oxygen. So not when we add oxygen scavenger, there is oxygen from the environment. So by using the low barrier of oxygen. How to calculate is very simple. Just A plus B. A means the quantity of oxygen, the initial quantity of oxygen in the packaging, and B is the estimation oxygen that can penetrate into the packaging during the storage. So this is why, and A just by using the volume of packaging minus the weight of product, because we assume that the volume specific of product is 1. So basically product converted into the volume. So basically volume of initial oxygen is volume of the packaging minus the weight of product. And B, we have to estimate how many oxygen penetrate the packaging during the storage. So we have to estimate by the equation S times P times P. S the surface area of the packaging, the surface area was from R, and P is permeability. So here for permeability, even we use multi-layer packaging with aluminum foil, 7 micron or maybe more than 7 micron. When we tested the oxygen permeability in the material, maybe 0. But in foam packaging, in foam the packaging, normally the oxygen permeability is not 0. Why? Because in the oxygen can penetrate in between the sealing, because in the inner layer mostly is PE, LDPE, low density polyethylene, or CPP, acid polypropylene. So in the inner layer of multi-layer packaging mostly is CPP or PE. So we know that CPP and PE high permeability of oxygen, very high, more than 2,000 milliliter per day, so per meter square. So and according to the permatron is one instrument to measure the oxygen permeability. They measure that normally when we inform packaging, still even when we use aluminum foil more than 7 micron in the layer, but inform the packaging, the estimation for permeability normally 0.05. At least we have to calculate this because in the ceiling, maybe there is leak or there is made from polyethylene, so there is still potential of permeability oxygen. And B means the targeted shelf life. For example, we have targeted 3 months or mostly for the snack more than 9 months. So we have to times So here according to our research, yeah. So for example, for climate sticky rice from Payakumbuh here. So without packaging technique, just by using polypropylene, yeah, the shelf life is just less than 10 days, or mostly sometimes only 7 days already change the taste, yeah, rancidity appear. Yeah. But by using oxygen scavenger combined with Fago, yeah, I can make a prolongation the shelf life until 3 months. So this is will be started, but maybe for the small industry, yeah, just recommend is increase the capital, this cost of production. And also for the steam cake, yeah, we can say, but maybe for the steam cake, the shelf life without oxygen scavenger is less than 1 day, or maybe one day is the maximum. But after by using the combination, yeah, oxygen scavenger with maybe with gas packaging, yeah, we can improve more than 7 days. Yeah. And when combining with the vacuum, we can achieve more than 1 month. Okay, for the snack also, yeah, we can increase the shelf life, yeah, by using the oxygen scavenger. Okay, I think for the second active packaging, ethylene scavenger, I will just talk a little bit because this is not for food product but for fresh product. But I think very important for that have business, for example, fresh cut fruit. Yeah. So by using the ethylene scavenger, we can extend the shelf life of our food. Yeah. Because ethylene is one hormone, important hormone. So here the commercial available in the market, yeah. Biofresh is a leader. Yeah, I have tested Biofresh for preserving fresh fruit. And let's move to the antimicrobial. Yeah, this is very important. I think the second one, active packaging that already acquired, yeah, is antimicrobial packaging. So we have 3 types of antimicrobial. Yeah, that means by using ethanol emitter, by using the film, or by using the coating, yeah, informed coating. Yeah. So this is by using the antimicrobial packaging. Yeah, we don't need to add preservatives, or we can minimize, yeah, the use of preservative, because when we put in the packaging, we need only very small quantity. Why? Because I have tested, yeah, in many product laboratory. Yeah. So on the right one, yeah, this is the system for preservative. That means when we, for example, when we make bread, yeah, we make the bread. So in the dough preparation, we add preservative. Mostly the preservative for bread is propionic acid, yeah, so in form potassium propionate. Very rarely we using sulfuric acid, because sulfuric acid is very effective to yeast. Yeah, when we use sulfuric acid, yeah, our bread cannot the proofing. Yeah, it's very limited the proofing. So we use mostly propionic acid. So I have tested one. I put as a preservative. Yeah, maybe we need 1%, 1% or 0.5%, and this is limited for maximum use, yeah, according to people. Yeah. And the left one, we can use informed coating. So I prepare coating solution, for example, from pectin or from ketosan, put with propionic acid. So what happened? Only very thin layer with the same concentration of the bread. So in total, when we on the right one, maybe when we eat 100 gram of bread, yeah, maybe we consume 1%, for example, 1% of propionic acid. Yeah, when we use concentration 1%. But on the left, yeah, it's very little. bacteria is polyus micro, mostly as aero, means they tend to grow on the surface, yeah, not in the inside packaging, so inside food products. So when we apply coating or film, it's very effective to inhibit the growth of bacteria, the growth of yeast, etc. Yeah. Okay, so the quantity less and more effective. So in our test, yeah, with the preservative, the just impact the 3 days, yeah, by using the coating, we can extend until 7 days. Yeah. Okay, yeah, here's the example for we can use antimicrobial packaging in form film coating and also emitter method, mostly by using ethanol emitter. So actually I still conducting research, yeah, by developing ethanol emitter combined with essential oil. So and have a very good impact, yeah, compared to ethanol emitter itself. So here and already available in the market, ketika kamu mostly in Japan. Okay, next. Yeah, this is a kind of active packaging that gives more convenience to the consumer. Yeah, so we can do the self-heating can. Yeah, maybe for the old style consumer. Yeah, drink coffee, drink tea is still agreeable. Yeah, still comfortable when we eat, when we consume in hot condition. Yeah, but maybe in younger have sense here using label, yeah, that responsive to the organic acid, yeah, comprised from the fruit. So this is very suitable for fruit that during the maturity the color of skin not change. Yeah. Maybe banana is not good, yeah, because banana from green, yellow, yeah, it's very easy to look at the ripeness of banana. But for example, here is pear. Pear here is the skin is not changed during the maturity. So when consumer want already ripe or consumer want still firm, yeah. So we can just look at the label. Yeah. So this is ripe sense. So here this for meat. Yeah. This is responsive to hydrogen sulfate. Yeah. Normally when there is spoiled meat, yeah, H2S is formed and then respond by using this from palm to prawn. And so this is the change color indicate the quality of the product. And food safety system by that we call toxin card the product in this to sense if whether contamination of bacteria, pathogenic bacteria mostly, yeah, in the product. So when there is the bacteria contaminated in the product, so we broke the barcode, so the barcode cannot be read by the cashier. Okay, normally for the time temperature indicator, sorry, why not? Can you back one, please? One more. One more. Okay, yeah. So this is, I think, this is very important for time temperature indicator, yeah, because this is can change the rigid expiration date, yeah, into interactive. So by using the time temperature indicator, we can look at the quality in real condition. So normally we have monitor 3M and so pizza, and so according to by using the mechanism diffusion, so the diffusion, the diffusion of the indicator is depend on the temperature. When product start at cold temperature, means the diffusion is slow. But when the product outside high temperature, so the diffusion will go faster. So maybe this normally when the expiration date only fixed 7 days, for example, yeah. Normally when store at room temperature, only 1 day is so. But in the expired date, still 7 days. Yeah. But by using time temperature indicator, we can say already achieved the expiration date. Yeah. By polymerization and also by enzymatic reaction for the pizza and UV degradation for ongo label. Yeah. So please, because I can see the how many minutes? Okay, so thank you. Okay, so this is very easy to develop normally, but we have in the manufacturer for this product, yeah, we have calculated the kinetic degradation of the material, yeah, and we can make correlation with kinetic
you.
Yeah.
Probably we can open for Q&A, just one question. Any of our guests have question? Okay. Just one question because we are already over time.
So,
My name is Gali from Vancouver. I would like to ask about the antimicrobial, especially for spraying with iron silver or iron, any kind of for antimicrobial.
yeah.
Do you have any experience with that, or is it also part of active packaging? Thank you.
Okay. Okay, so thank you very much for your question. So when we spray the iron, when we application during the process, so this is not included in the active packaging, but this is a processing it during the process. Yeah. This is good because we need to remove many methods, yeah, to remove bacteria, to remove the microbial, yeah, by using one kind this thermal process, by using the one is type as by using, for example, additive. Yeah. When we apply spray, means during the process. Yeah, I think it's not included in the active packaging. But when the spray is included in PET, for example, yeah, and release slowly, yeah, during the storage, yeah, we can put inside the packaging. Yeah. So we can categorize this as active packaging, antimicrobial packaging. So, but I didn't hear the commercial use iron silver, yeah, as antimicrobial in antimicrobial packaging. But maybe in foam film, yes, because I'm personally I have conducted many research to develop antimicrobial film, yeah, by using nano composite technique here. Maybe nano silver, for example, yeah, maybe spray silver here is informed to form the nano composite film that act as antimicrobial film. So when contact or when as a coating, we can inhibit the growth of microbial and on the surface of the food product. Yeah, I think so. Depend on the application. When apply in the foam film pad, we can categorize as active packaging, yeah, as antimicrobial packaging. But when we apply during the processing, yeah, we can say this as processing aid. Yeah. For example, for the water treatment, sometimes also we use iron silver, you know, one to um, to replace the ozonization, yeah, in some technology. Thank you. Okay, thank you very much for your attention and your feedback. If you have questions, please you can send by email or by contact, yeah, directly. Thank you very much. Yeah.
Thank you, Dr. Nagara. Okay, for our next presentation, the speaker recorded his presentation, but he will be answering Q&A live. So let's all welcome Suhas from CEO of App Chemi. He will be talking about advanced recycling technology enables cost-effective operations. Let's all please welcome Mr. Suhas.
Let me begin by thanking Richard for this wonderful opportunity to connect with all of you at 2023 Asian Manufacturing Summit at Jakarta, Indonesia. I really wanted to be present there personally. I attended a Ranger conference like this a year before COVID started, and I really enjoyed the energy in the room. This time, because of some commitments, I couldn't be there personally.
Very good morning, everybody.
Presentation,
Uh,
very happy
Let me begin by thanking Ranger for this wonderful opportunity to
questions
connect
you
with
have
all of
on
you
this
at
wonderful opportunity.
2023.
So I'm looking at somewhere around 20 minutes of presentation, and then followed by maybe around 10 minutes of question and answer. So
2023 Asian Manufacturing Summit at Jakarta, Indonesia. I really want really wanted to be present there personally. I attended a Ranger conference like this a year before COVID started, and I really enjoyed the energy in the room. But this time, because of some commitments, I couldn't be there personally. This is a recorded presentation, but I am also here online. So at the end of the presentation, if you have any questions, we can take up that as well. So I'm looking at somewhere around 20 minutes of presentation, and then followed by maybe around 10 minutes of question and answer. So my objective is to ensure that by end of this presentation, make you understand how advanced plastic recycling technology can be made cost effective, and what is our take on this to make it cost effective and sustainable. So let's start. Little bit about me. I am Suhas Dikshit, founder and CEO of AP Chemi. I'm formally trained in chemistry, chemical engineering, marketing, and contract management at Institute of Chemical Technology, IPER, IIM Ahmedabad. I'm inventor of technology since 2007. I have 12 patents in my name, three granted in India, one in South Africa, and few of the patents are also undergoing positive examinations in Europe, USA, and Canada. My core expertise is in pyrolysis, purification of pyrolysis oil, as well as chemical advanced recycling of end of life plastic waste. About my company, AP Chemi. AP Chemi as a company, we are leaders in pyrolysis. We turn non-recyclable plastic, tire, and biomass waste into value. So these are some of the visuals of the projects that we have developed across the world. We have developed 47 pyrolysis plants since 2007 to process plastic, end-of-life plastic waste, biomass, as well as tire waste. We focus on reducing emissions. We are also supported by Shell Petrochemicals through their Shell E4 platform. Earlier this year, we raised $2.4 million of research funds for producing green hydrogen from plastic waste in collaboration with Aalborg University, Denmark. We are working on global projects of capacity up to 240 tons per day of plastic pyrolysis in Europe. We recently completed an engineering assignment for a different client in UK to set up a 42 tons per day of plastic pyrolysis plant. All these projects that we've done, over 47 projects across the world, have created more than 3,000 jobs globally. And recently, our focus has been to produce proof of concept on how you can start with end-of-life plastic waste, like post-consumer plastic waste, empty pesticide containers, multi-layer packaging, non-recyclable mixed plastic waste, and process it through our pyrolysis and oil purification technologies to produce feedstock that can go in for chemical recycling of plastic waste. So these are the kind of proof of concept assignments that our R&D is extremely busy with these days. Our efforts have been recognized by various organizations like KPMG. Last year, we also have won FICCI's Disruptive Circular Technology Award. in addition to that, we are supported by ecosystem of partners, supported by Shell E4, Act Capital, Department of Science and Technology, Government of India. We have a, HEC Paris platform at Station F. Technip Energies has given a press release that they want to market our technologies. KPMG is supporting us, Alliance to End Plastic Waste. We are collaborating with medium scale players like River Recycle Finland, as well as players across the world to collaborate and accelerate plastic circularity. And not only with industry, we are collaborating a lot with academia across India, UK, Europe, Australia, and we are open to collaborations with academia across the world to find common ground, find opportunities to accelerate chemical recycling of plastic waste. So now let's get into the technical part of the presentation. When we look at the different types of plastics that are available, the only recycling that is happening these days is mechanical recycling, really. Around 10% of plastic that is recycled through mechanical recycling, except that PET has somewhere around 80 to 95% of recycling rates, depending on whether you count for child labor or not. So if you don't worry about child labor, PET actually has recycling rates of like almost 90-95% in India. If you discount the child labor, then it probably is somewhere around 80%. Similar are the problems across most of the parts of Asia, Africa, and South America. But polyethylene terephthalate chemical recycling is not really a problem to be solved. That problem has been solved. The problem that is to be solved is for mixed plastic waste of HDP, PVC, LDP, PE, PP, polystyrene, and non-polyolefinic plastics. When all of this gets mixed, that kind of plastic waste is not recycled, 90% of that. And you can do downcycling by doing compression molding, by making, say, school benches or doors out of this. But this compression molding business is not really scalable. I mean, there's a limit to how many school benches can we make or doors can we make. And then final option that we have to fall upon is chemical recycling of plastic waste, which has two options. You can do pyrolysis or gasification. Based on the factual data, pyrolysis has much wider acceptance across the world compared to gasification. Gasification in very few use cases can become sustainable, especially if the refinery has a gasifier and that gasifier can take plastic from nearby around maybe 200 kilometers away. But apart from these special situations, pyrolysis tends to be far more straightforward, dependable, and predictable option compared to gasification. In case of gasification, you have to take plastic, convert it into syngas, convert syngas into alcohol, and then convert alcohol into a feedstock that can go into refinery. So it's much longer process compared to pyrolysis and oil purification, which is far more straightforward and predictable as such. This is where we specialize as a company. Now, when we start discussions of chemical recycling, we need to be convinced why we should do chemical recycling. And we look at big picture. Less than 10% of 350 million metric tons of plastic waste is recycled. Rest of the plastic waste is going to landfill, environment, and incineration. Currently, around 350 million metric tons per annum of waste is generated, which will increase to around 450 million metric tons per annum by 2030. Right now, around 100 million metric tons per annum of plastic waste is going for burning, which will increase to somewhere around 150 million metric tons per annum by 2030. And we shouldn't really burn plastic if we can chemically recycle it. Now, if we combine the chemical recycling ambitions of all 5 global petrochemical companies mentioned here, based on the public data, they would have ambitions of chemically recycling, let us say, 10 million metric tons per annum of plastic waste. But still, there is a huge gap between the current ambitions and compared to how much we are going to burn and send to landfill, fires and all. So This is one of the reasons why scaling up of chemical recycling is necessary to substitute burning of plastic waste for sure. Burning of plastic waste right now every year generates 300 million metric tons per annum of carbon dioxide footprint. Plastic gets burned in incineration plants as well as landfill fires. Now, from now to 2023, humanity will burn additional 1.2 billion tons of plastic waste, resulting into 3.5 billion tons of carbon dioxide emission, which is a huge contribution to global warming. We don't realize how plastic is contributing to global warming. Now, to make progress on these challenges, a lot of legislations are driving the industry growth of chemical recycling. And as is the case, Europe tends to be mother of all legislations. Environmental legislations, first environmental legislations come in Europe and then they get adopted across the world. So extended producer responsibility came in Europe and then it got adopted across the world. Similarly, plastic tax has come in Europe, and now a couple of countries in Australia have adopted plastic tax, and plastic tax is being discussed amongst the policymakers and legislators across the world in each country. Carbon footprint tax will prevent the plastic waste going into the incineration plant. It will prevent it from getting burned in landfills. And legislations like European circularity targets, recycled content targets are getting copied across the world. Like India now has very clear targets for recycling, very clear targets for recycled content. So these legislations are coming up across the world, and that's what is driving the growth of this particular industry. Now, getting a little more technical, the core problem is poor quality of pyrolysis oil that disables chemical recycling. When you take mixed plastic waste, multi-layer packaging, having polyvinyl chloride, polyvinyl dichloride, polyethylene, polyurethane, rubber, soil, and metal, you take that plastic waste and convert it into pyrolysis oil using conventional technologies. What you get is a bad quality pyrolysis oil, which has chlorine, bromine, acid, sulfur, silica, oxygen, nitrogen, metal, heavy metal, and all these impurities cause problem for refineries and petrochemicals. So nobody wants to really buy this kind of pyrolysis oil. Now, to solve this problem, what we figured out is that AP Chemi can take mixed plastic waste into its technology, or we can take contaminated pyrolysis oil as a feedstock and produce purified pyrolysis oil, which can be used by petrochemical and refinery for production of circular plastics and sustainable chemicals. So if you have to look at a block flow diagram of chemical recycling process, this is how it will look like. So you start with post-consumer plastic waste, which is not recyclable. Either you take non-recyclable plastic waste, push it through AP Chemi technology and produce purified pyrolysis oil, or you take contaminated pyrolysis oil, push it through our technology and produce purified pyrolysis oil. And this purified pyrolysis oil is a good feedstock to substitute crude oil sourced feedstock and produce circular plastics and sustainable chemicals out of it. So those sustainable chemicals and circular, like sustainable chemicals, example being say linear alkyl benzene, which has a carbon chain length of less than C14. If anything is less than C14, it tends to be biodegradable, so that it's sustainable. So produce circular plastics or sustainable chemicals, which can be used by FMCG in packaging to supply it to the consumers. And this is how your carbon is chemically recycled. What our technology does is removes the contaminants from the pyrolysis oil or plastic waste and produces purified oil, which can be used in the existing refinery and petrochemical assets. These are some colors on pyrolysis oil purification technology of AP Chemi, how it performs. So we've been able to remove up to 99.7% of chlorine impurities, 99% of oxygen, 98% of bromine, nitrogen up to 73%, and then other impurities as well. Now, the core problem is halogens. You can say 70-80% importance you can give to chlorine and bromine impurities put together, because these impurities are also corrosive. Once you knock out the corrosives, then you can do something with that kind of a raw material in the process plant. So our oil purification technology always reduces the chlorine content from around 2000 to 4000 ppm to less than 250 ppm to less than 100 ppm. And once we get it to anything less than 200 ppm, then you can profitably use adsorbents to further polish the pyrolysis oil and put it into a refinery complex. So what we do is that we remove major amount of the impurities so that use of adsorbents becomes commercially viable, and then this oil can be chemically recycled as a raw material into the refinery and petrochemicals. We have validated our technologies and proof of concept. We supplied oil samples. We've been working with global petrochemical and FMCG companies, and we've received 8 written letters of intent for oil offtake from global petrochemical and FMCG companies. Our cost-effective APChemy technologies can be classified into pyrolysis technology and pyrolysis oil purification technology. So pyrolysis oil technology that we have is highly energy efficient. It is safe. We have 0 accident history, even though we have done 47 projects. We have very high tolerance for metal and stones. The input to our pyrolysis projects is flexible. Input can be adjusted anywhere between plastic, tire, and biomass based on the market availability of these raw materials. We've developed 47 projects that have processed 179 million kilograms of plastic, over 1.3 million hours of operation. So there's a fantastic track record to our technology as well. Pyrolysis plants that we have developed have around 330 working days of uptime per year, and we've got 5 patents in pyrolysis. Now, pyrolysis technology very well complements with our pyrolysis oil purification technology. Because we have pyrolysis oil purification technology, we don't need very great quality feedstock for pyrolysis. We can start with a contaminated feedstock, get contaminated pyrolysis oil, but still purify it using our oil purification technology. So that's the advantage. You can use wider variety of feedstock for pyrolysis because you have pyrolysis oil purification technology downstream. So our oil purification technology is highly energy efficient. It minimizes the use of chemicals, and this high energy efficiency and lower usage of chemical actually reduces the scope 2 and scope 3 emissions. We thereby also reduce the cost of purification of pyrolysis oil. We remove corrosives and catalyst poisons that can affect the operations of downstream partner, and oil purification technology has 340 days per year of uptime, and we've got 7 patents in it. Now, whenever we think of a technology and selection of technology, one of the important things that we have to look at is what is the carbon footprint. So this is the slide which shows you how APChemy technologies reduce emission by 50 to 75%. And enable low carbon circularity for food and pharma grade packaging. So many times chemical recycling, the moment we say chemicals, people are a little scared whether, chemicals is really good for environment or not. But you have to always compare to what? So if you compare chemical recycling to burning the plastic waste in incineration plant, or burning the plastic waste in landfill fire, chemical recycling via our technologies has much lower carbon footprint. So if you look at kilograms of carbon dioxide per metric ton of end product produced, our technologies has around 20% lesser carbon footprint compared to producing plastics via conventional pyrolysis technology. So compared to conventional pyrolysis technologies, our technology enables plastic circularity at around 20% lesser carbon footprint. And plastic production from crude oil has around 10-15% more carbon footprint compared to our technologies for chemical recycling. We are able to reduce the carbon footprint because our technologies reduce the use of chemicals. We figured out how to minimize the use of chemicals in oil purification, also increase the energy efficiency of these processes. Uh, Now, we can produce certain other chemicals from plastic waste that we can discuss across a non-disclosure agreement. Now, just for disclaimer, we should, I mean, the feedstock from mechanical recycling can never be used for chemical recycling. If you see, say, 99% of pyrolysis plants across the world, they process end of life plastic that cannot go for mechanical recycling. So chemical recycling can never afford a feedstock that can go for mechanical recycling for commercial reasons. So chemical recycling would never take feedstock away from mechanical recycling, but just for comparison purposes, the carbon footprint of chemical recycling is not very different from the carbon footprint of mechanical recycling. And these two technologies have very similar carbon footprint as such. So it's not that bad. Chemical recycling as a word might not sound so appealing, but then it, as from carbon footprint perspective, it's not that bad compared to other options. And our technology is able to even further reduce the carbon footprint of chemical recycling by around 20% by reducing the use of chemicals. Now, this is the second last slide, and even though this is not a technical slide, this is very much a practical slide, and this is the reality of our world. Um, if you see 99% of investments in plastic waste management in chemical recycling projects are happening in USA, Canada, Europe, and Australia put together. But where is the plastic waste mismanagement? The center of mismanagement of plastic waste is Africa and Asia put together. So there is a huge amount of disconnect between where the investments are happening and where the mismanagement of plastic waste is there. Where is the need for chemical recycling? And this global challenge, it really demands for collaborative fundraise effort. We should come together. We as a technology and engineering and equipment company, we are very keen to collaborate with plastic collectors, city councils, contractors of municipal corporation, petrochemical companies, FMCG companies, packaging companies, investor community, and start developing proof of concept that, okay, how it can be made viable. Can we prove this at R&D scale? Can we scale it up a little bit? Can we demonstrate using our existing assets that we have by processing certain qualities of plastic waste? And how can we develop a proof of concept that we can start with bad quality?
Right. Please wait for a few seconds. Mr. Suhas, do you hear my voice? Please turn on microphone and camera.
I can hear. Yes, I can
Can
hear.
you say something? Okay,
Good
good.
morning. Suhas
Morning.
speaking.
Morning.
Thank you. Executive.
Can you hear me well?
Yeah,
Okay.
I'm here
Okay.
in
Okay.
this venue. So
Okay.
I very appreciate the whole explanation that you are talking about. I agree with you that the chemical recycling is the only good solution for especially for polyolympic. For example, here in Indonesia, we are already having three company that's already making recycling for polyester or PET, but
Yep.
the
Yep.
polyolefin, I believe, not really. I know that Unilever may be having some venture in that, but it's not really successful. So the chemical recycling again,
Mm-hmm.
uh, According to my information that I got, for the time being, for the upcycling of these flexible packaging, definitely the only solution is the chemical recycling. But the challenge is regarding the cost. The cost. So
Mm-hmm.
from your presentation that this morning, that you are working mostly with the eight giant petrochemicals, and
Mm-hmm.
that seems to me that that is the only way that you can really going forward with the chemical recycling technology. So
Mm-hmm.
that's why my question, according to your experience in India, maybe, do you think that in the future that the chemical recycling really can be, let's say, in terms of economy of scale, that you are able then to replace the whole fossil-based resources that we're still using a lot now. And if we are talking about the giant of petrochemicals, of course, they will really try to balance between according to the raw resources or the recycled resources based on the cost. And at the time being, of course, the cost of the recycled is still higher, especially in this moment where the raw material, the raw feedstock is much lower in price. What do you think in the future? What is the solution in the future in that case in order that chemical recycling can really going forward, going upwards? Thank you.
Uh, Thank you. It's a very interesting question, and um answer would involve like whether the question is whether chemical recycling would be really be scalable in future, and can it really substitute plastics from crude oil. Um, so it depends on multiple factors. The first factor is the price of the crude oil. If the price of crude oil is going to be very high, that's really great for chemical recycling. But even if the price of crude oil remains somewhere around, say, $70 per barrel, that offers some kind of stability for chemical recycling. If price of crude oil goes to 30, $40 per barrel, that then there will be a lot of motivation for petrochemical companies to use crude oil based feedstock rather than chemically recycled feedstock. So price of crude oil is one factor. Another factor is uh, legislations. So legislations like extended producer responsibilities are helpful, but it's not really enforceable. The moment you come up with a legislation that includes the term tax in it, that's really enforceable, because uh, uh, not filing correct taxes is a very huge offense compared to not doing some amount of your extended producer responsibility. So the moment you call it plastic tax rather than plastic EPR, the amount of accountability increases a lot. So wherever plastic tax comes up, their chemical recycling will very fast become mainstream process of dealing with most of the plastic waste, because most of the plastic waste is not mechanically recyclable. So plastic tax is something that would also help. And the third factor that would help is cross value chain collaboration. Cross value chain collaboration, which really doesn't exist these days. Cross value chain collaborations means consumers don't segregate the plastic waste. They don't worry much about plastic segregation facilities. Plastic segregation facilities are not designed to provide a quality feedstock for pyrolysis plants. Pyrolysis plants don't know how to purify the oil. Petrochemical companies don't talk openly with pyrolysis companies that, okay, this is the exact specification of oil that we need. There's no open, publicly available specification of oil that is available. Petrochemical companies want to keep larger amount of profits by selling recycled plastic and pass on minimum amount of that to the pyrolysis company. So there's good amount of disconnect between pyrolysis and petrochemical industry. once petrochemical industry produces polymers and it sends to packaging and FMCG, packaging and FMCG wants to create a packaging that can impress the consumers, and that makes packaging complicated. They mix polyethylene terephthalate, PVC in and make mixed multi-layer packaging, which is not that straightforward for chemical recycling. That's where our oil purification technologies help. But again, so there's a good amount of cross value chain disconnect between the consumer, the pyrolysis companies, even city councils, contractors of municipal corporations, FMCG, petrochemical company. These are all stakeholders in the chemical recycling of plastic waste, and they are not talking to each other. So platforms like Ringer help us, all of us, to come together and figure a solution out, which is great. So it's a also, like, last factor is that one thing that we have to understand is that chemical recycling ultimately is a chemical process plant, and chemical process plant should be de-risked in less than 30% of capex. In case one is not able to de-risk the chemical process plant in less than 30% of capex, then probably they don't know how to set up these kind of plants. So you have to go through the substantial amount of planning by developing a proof of concept, observing the reaction at an R&D scale, developing a proof of concept, getting oil quality approved by a petrochemical company, and having a long-term contract at a stable price. So a lot of planning and de-risking is required in initial planning phase. The projects that don't go through that necessary planning and de-risking will suffer financially later on. So these are the multiple factors. Chemical recycling is, as you mentioned, is not a mainstream industry right now. And these factors, all of us working together on this would probably make this, I mean, polyethylene terephthalate chemical recycling has reached 95% efficiency now. So polyolefin waste also can reach 80, 90, 95%, but then it also depends on all industry players and legislations coming together. Yeah. Do we have any more questions?
If we have any, and our delegates, we will pause for a coffee break, and when you come back, please come back around 20 minutes after, and then we will start our last session, which is panel discussion. Okay, so see you. Please don't forget to
Mr.
visit
Suhas,
our meeting outside.
our moderator just announced that if they have more questions, we invite them to email to you later.
Okay, cool. All right.
Okay, waving goodbye to the delegates.
Bye-bye. Bye. Thanks everyone. Bye. Bye. Thanks. Bye.
Thanks, Suhas.
东莞克尔汉机械有限公司。
Foshan BJY Precision Technology Company Limited, located in Sanshui District, Foshan City, Guangdong Province, was founded in 2011. It's a high-tech enterprise. The plant covers an area of more than 4,000 square meters and has more than 100 employees. After 1 decade of steady development, BJY has developed into an influential manufacturer of molds and equipment for the PET liquid packaging industry. Our products include blowing molds, injection molds, compression closure molds, and other related spare parts. Why do world-famous brands such as Coca-Cola, Toyo Beverage, Watson's, Jianlibao Group, China Resources Chesterban, Uni-President Group, and Costco Group choose BJY? Because we have 3 core advantages. Firstly, we have a professional technical team to provide you with one-stop service. We have a group of engineering and technical personnel and production workers who have 20 years of work experience in PET packaging industry. They can provide customers with a complete set of services from perform, bottle design, product R&D, and molds production. Secondly, we have complete production and testing equipments to provide you with high-quality products. From raw material monitoring to finished products, each process has undergone strict control. After years of development, we have formed our own complete production and inspection process. Meanwhile, we continuously increased on the investment, purchased more than 40 high-precision processing equipments, such as mirror-grade EDM machines, fast-turning milling compound machines, Jingdao 4-axis and 5-axis CNC, etc. Our inspection center has more than 30 sets of precision inspection instruments or equipments, including TIE's 3 coordinates measuring instruments, Kian's image dimension measurement system instruments, etc. Precision inspection equipments help us achieve comprehensive quality control. Thirdly, we provide you with the most reliable services and sincerely create values for customers, adhering to the concept of trying to reduce the probability of problem and solve the problem in time. From the pre-sale product design, mode surveying and mapping, to prototype modes testing, and lot size mode production in sale or after-sale on-site debugging. Foshan BJY Precision Technology Company Limited.
Zhongshan Smart Weight Packaging Machinery Company Limited is professional in manufacturing auto weighing and packaging machinery and offers smart automation factory turnkey solution. Exporting over 50 countries, 80% for exporting, 20% for domestic market. Annual production capacity is over 1,200 machines per year. 8 skilled after-sales service standby to offer positive and professional service for all customers all over the world. Sales and engineering team always offer professional solution according to different customers' requirements. All machines will be all-stage testing 7 days times 24 hours before shipment to make sure running perfectly in customer production. As a high-tech enterprise with many patents, we focus on R&D to create new technology service different projects. We are strongly in fresh meat, sticky production, auto weighing, and packing solution. Zhongshan Smart Weight Packaging Machinery Company Limited should be your smart way to get the smart automation factory. Adhering to the business principle of mutual benefits, we have had a good reputation among our customers because of our perfect services, quality products, and competitive prices. Reasonable price, trusty quality, and high-quality service are our everlasting principle. We warmly welcome customers from domestic and abroad to cooperate with us for common success. Our company always adheres to the principle of providing customers with satisfactory products. Here, invite customers from all over the world to visit our company and work together for a brilliant future.
东莞科尔汉机械有限公司位于广东省东莞市石碣镇，是专业生产塑料成型周边机器的高技术企业。
我们科尔汉是一家塑胶周边设备高新技术制造商，主要产品有除湿干燥机、称重计量混合机、集中供料系统，主要应用于挤出、注塑、吹膜、临摹等行业。我司注重整体化定制、后期延伸的服务。
谈起科尔汉，我们从创办开始，买第一条设备线的时候，就由科尔汉公司来为我们这个服务。你要问我谈这家公司的最让我满意的地方是什么？我觉得这家公司首先是领导的价值观非常好，然后呢，他们的这个整体的服务团队也非常的配合，特别及时。谈到产品呢，我觉得它的有很多优点。第一个是产品稳定，第二个，他们这个设备在设计的时候啊，引进了一些国际的思维，它们节能性也是非常好的。我们也很感谢科尔汉对我们这么多人的服务，帮助我们提供了很多套解决方案。那我们在生产能力上做了很多提升。最让我感动的就是他们的态度，服务态度，这个特别真诚、特别真实，然后也特别踏实那种。我建议，业界朋友多考虑这家公司，多去跟这家公司接触，我相信他们会给你带来和我一样的感受。
我们基于满足客户的需求，为客户创造价值的理念，以创造性的思维，在新设备的开发研究方面做着不懈的努力。 为电子、汽车、家电、光盘、建材、包装、饮料、医疗等行业的塑料加工提供以下高品质的系列设备：原料集中供给系统、全自动除湿干燥输送系统、PET、PETG 挤出生产专用原料结晶除湿干燥输送系统、PET 平胚及吹平生产专用原料除湿干燥输送系统。PC 光学片挤出生产专用原料除湿干燥输送系统 ，PEX 管材挤出生产专用原料除湿干燥输送系统，高精度模具温度控制机、冷水机、模具结露防止机、多方向原料自动输送机、全自动失重式、增重式精密计量配混系统。色母粒及粉碎料自动比例配混机、粉碎机、粉碎料再生使用系统，以及有关成型工厂从初期规划咨询开始，延伸到投产后的全方位服务。科尔汉的 PET 树脂结晶干燥系统设备，以及公司丰富的干燥技术、程序化的电脑控制技术以及高性能的电子机械技术为基础，高效地解决了困扰在片材的挤出生产过程中所产生的片材脆化、含水分解、粘度降低、酸化裂化等品质问题。科尔汉的 PET 树脂结晶干燥系统设备，以均匀稳定的结晶化及除湿干燥为挤出生产线，连续稳定地提供干燥完成的 PET 树脂原料。如果您正在寻求解决塑料原料的输送、干燥、混合、计量、粉碎等技术问题的方法，您就正好是我们的客户。您的需求就是我们的义务。可靠、经济、安全和公平是我们为客户提供全部服务的基础。
Foshan BJY Precision Technology Company Limited, located in Sanshui District, Foshan City, Guangdong Province, was founded in 2011. It's a high-tech enterprise. The plant covers an area of more than 4,000 square meters and has more than 100 employees. After 1 decade of steady development, BJY has developed into an influential manufacturer of molds and equipment for the PET liquid packaging industry. Our products include blowing molds, injection molds, compression closure molds, and other related spare parts. Why do world-famous brands such as Coca-Cola, Toyo Beverage, Watson's, Jianlibao Group, China Resources Chesterban, Uni-President Group, and Costco Group choose BJY? Because we have 3 core advantages. Firstly, we have a professional technical team to provide you with one-stop service. We have a group of engineering and technical personnel and production workers who have 20 years of work experience in the packaging industry. They can provide customers with a complete set of services from perform, bottle design, product R&D, and mold production. Secondly, we have complete production and testing equipments to provide you with high-quality products. From raw material monitoring to finished products, each process has undergone strict control. After years of development, we have formed our own complete production and inspection process. Meanwhile, we continuously increased on the investment, purchased more than 40 high-precision processing equipments, such as mirror-grade EDM machines, Haas turning milling compound machines, Jindal 4Xs and 5X CNC, etc. Our inspection center has more than 30 sets of precision inspection instruments or equipments, including TIE's 3 coordinates measuring instruments, Kian's image dimension measurement system instruments, etc. Precision inspection equipments help us achieve comprehensive quality control. Thirdly, we provide you with the most reliable services and sincerely create values for customers, adhering to the concept of trying to reduce the probability of problem and solve the problem in time. From the pre-sale product design, mold surveying and mapping, to prototype mold testing, and lot size mold production in sale or after-sale on-site debugging. Foshan BJY Precision Technology Company Limited.
Microphone? Yeah, find the tech guy.
Find the tech guy.
Will be reciting the answer questions.
Companies growing through smart manufacturing and digitalization, it entails additional costs or higher expenses. So where do they start, given that they have constraints on their budget? And which aspect of manufacturing or packaging production should be prioritized? So that's one of the questions over there.
Okay, thank you, Ben, for the question. I think just to repeat the question, I think for companies that want to start digitalization, right? I think where do they start?
Here's the question. For some companies going into smart manufacturing or digitalization, this entails additional or initial higher initial cost. Where do you think they should start? And which aspect of manufacturing or packaging production should be prioritized?
So, in a nutshell, that's the million-dollar question, right? So, I'll approach it in a number of ways. Yesterday, I shared about where do you want to start or how do you want to start your digitalization journey or your digital transformation journey. So, first of all, I think you need to do assessment and understand your priorities, your pain points, right? And which of the available solution or technology out there that can give the biggest impact, right? The biggest returns, right? And keep in mind that you cannot do it all in 1 or 2 years. You have to start like somewhere, and then you have to continue the journey and prioritize that, right? I think when we talk about the different solutions, right? I think there are ways to look into what are the priorities, and I think it's all about putting or allocating the budget for that. So I do not believe that the digitalization technology is very high cost always. Actually, when the technology matures as what it is now, actually the cost has gone down very significantly, right? But it's all about allocating. I think the rule of thumb, for example, is that you have to spend like anywhere from 1 to 2% of your revenue every year on digitalization and smart manufacturing technology.
over 30 years that in the packaging business, that all the time we are talking about how to reduce our costs, cost saving and so on. So, for example, like, yesterday there was a mention also by Franklin that the OE is a continuous way that we are doing in order to really manage how to cost saving and so on. So OE is regarding the availability, what you are scheduling and so on, and then productivity, the performance, and then the quality. So it's very, very good way in order to manage that. But I said, especially at present, I know a lot of company today is struggling. Our profit margin is getting lower and lower, frankly speaking, because of competition. Because a lot of competitors coming, raw material are not really stable in price and so on. It's very, very much difficult. So that's why with the OE system, for example, usually that we are doing a kind of a teamwork once a month and so on. But today it's not good enough. If 1 month that you analyze that, that's already too late, I would say. Today it should be real time. So that's why the digitalization is very, very much important today in order that you really can manage that much precisely, much in time and so on. That is very much important in our case right now, in order to survive. Yeah, some of companies really very, very difficult to survive today. So that's why, again, the digitalization with the whole technology that we have today, available today, the machine, the system, digitalization is not regarding only the hardware. The software is so important. That's why, because we are human, having all the limitation, I would say. Yeah, our memory is not, especially in the packaging business, we are job order. So in repeating the job, usually is very much difficult to consistent, to make a consistent quality, consistent productivity, whatever. This is a human limitation, I would say. So that's why with the whole tools that we have today, with the digitalization, and even with the artificial intelligence and so on, yeah, you know that, and that is very much helpful. And again, agree with that. We are not really focused on our capex only, capital expenditure. Could be that you have to invest, but you have to consider that in the future, how you make it sustainable in order really manage the OPEX, the operational expenditure. So that is very much important, I think.
Okay, thank you very much, Now for Wilson, recycling rate in Indonesia remains low. What measures or regulations do you think are needed to raise the recycling rate? So, what regulations would you recommend to increase recycling?
Okay, thanks for the very important question. Recycling rate, I have to say, is one of the key indicators, not the only, but one of the key indicators of how successful we are in our transition towards a circular economy. And currently it's, for Indonesia, it's around about 20%, because we have about 7 to 8 million plastic consumption annually, and the total installed capacity for recycling facilities is at about 2 million tons annually. But none of them are running at full capacity. So by doing the simple calculation, we get around 7%. But a lot of these companies, the recyclers, apart from those PET recyclers, but primarily also the PE and PP recyclers, who actually in total they have larger capacity compared to the PET most of these recyclers are small to medium scale enterprises, and they are not really, their presence is not really visible to the general industry. So meaning that the exact level of recycling rate that we have in Indonesia is still, not really transparent. That's given the nature of the industry at the moment. However, going back to the question on how we can achieve a higher recycling rate, I think it's a problem which we should approach it in multiple directions. All stakeholders in the plastics value chain must play a part in achieving a higher recycling rate. The governments, be it local governments and the central governments, have a very important role in setting up the regulations and making sure that the waste management in place is supporting that of the recycling, especially the recovery of the recyclable plastics. The converters, the brand owners, they must come up with a design, packaging that is designed to be easily recyclable. The collectors, the aggregators, we must work collectively in order to collect more plastic waste. And the recyclers, we must also address the quality challenge in order to make sure that we are not downcycling the plastic, but we are reviving the life cycle of that plastic back into what it was originally used for. For the society, I think it's also important to opt for packaging or plastic products that is made containing recycled content. And that in Asia, I think is still generally quite challenging because the perception of recycled plastic in Asia is typically seen as a more inferior quality compared to the virgin plastics. To sum up, I think everybody on the value chain must do their part in order for us to collectively achieve a higher recycling rate.
Thank you very much, Mr. Now, this third question is for all of you. This is quite a general question, but I would recommend that you discuss only the key points based on your expertise. So, do you have any further recommendation for Indonesian companies wanting to be globally competitive? I guess this is more like a final word.
Start the answer. Yeah, I think this 2 days event that we learned quite a lot. So for me, it's Indonesia especially. I'm always talking about we need to collaboration. That was the key point yesterday. Innovation and to accelerate everything. So that's why I always think that we need to improve everything. There's a 4 pillars in our ecosystem in order to make it circularity really working. First is regarding the operational. You see that some of the speakers yesterday regarding the waste management, for example, the post-consumer waste that we have to collect, we have to separate, and we have to recycle. That is the best way in order to make it circularity. The second pillar, that is you want or not, some are not really, that's what I mentioned yesterday, it's not valuable. So financing is very much important. So in order to make the infrastructure, to make the ecosystem working, you have to build the infrastructure. So financing. So one of the solutions, of course, that started with the multinational company here in Indonesia as well, that they have a kind of initiative in order to make it extended producer responsibility, EPR. That is in order also to give, to collect and financing as well for the infrastructure. The third part is technology. So you see, this morning we heard about the then the last one is the governance itself. I know what the regulation, for example, the implementation is not working, I would say. And then education, this is part of the governance as well, and the standardization, whatever. So that's what we need really to do this kind of a formula in the future.
If I can add to that, first of all, before I go to that, I think Henry mentioned about ecosystem, and I think that's very important to have ecosystem of different collaborators, partners, academics, professionals, and business players, business owners, and so on and so forth. And the government, of course. I was very encouraged with the presentation from Dr. Nugraha just now, right? It's quite enlightening for me, and I think that's kind of the good work that can be brought into the industry to strengthen the whole processing technology, right? And the product that we ship out to customers in Singapore, in Indonesia, or elsewhere globally. I'd like to cite two examples how I think the food, beverage, and packaging industries in Indonesia can contribute and even compete globally. Right? The first example is actually from my customer. They are in Batam. They have a factory in Batam, and they basically manufacture the coffee machines for different MNCs, and one of them is Nestle. Right? So about 2 years ago, or about 3 years ago, we started engagement with them, and we do a lot of things for them. And just recently, we went live on 3 different solutions, digital solutions that we implemented there. The first one is advanced planning and scheduling. The second one is what's called the MES, Manufacturing Execution System. And the third one is the HR management system, the human resource management system. Now, one of the reasons why they implemented MES was because every time Nestle came to their factory, Nestle would be asking, you don't have MES, how come? Right? So that's always every year that's always the questions they working with this customer, this company, right? And by the way, it's not a local company. They are in Batam, but they're actually a German contract manufacturer. So they have no choice, right? Because Nestle is basically telling them, if you don't have the MES, I'm not going to give you a new project, right? So they have to go with that, and by doing that also, actually they have not only fulfilling what the customer wants, but they also see the benefit of that, right? Advanced planning and scheduling basically will help them to optimally schedule their production so that they can produce more with the same number of machines, for example, things like that. The second example is not a very good example, but I use this example without naming the name, right? But I think this is just to give you an example how we can actually be more competitive if we do things right, if we adopt the right technology. This is a company actually somewhere in Bandung, right? And they are producing snack, right? So I've been to the factory, and basically, the whole warehouse is full of boxes of finished goods that all stuff stacked up. There's no warehouse management system, and there's basically there's no FIFO, first in, first out, and all stuff, right? And the first question I asked is that what happened to those boxes at the bottom, right? They start to crumble, for example, because they stack up so high, right? And they said, well, if it's really crumpled, we probably throw it away, or we're going to sell it to the retail shops at a lower cost, discounted price, right? So imagine if a customer from elsewhere come and visit and audit them and see this, what would the customers or the potential customers would think? Well, I don't think I want to buy from this customer, or from this supplier, right? They can't even manage their warehouse properly, right? This company is actually doing very well. They buy lots of shared yesterday, is software is invisible. Everybody thinks that, oh, I can do it myself. I am a programmer. I like programming. I have been doing programming. Now I can't do programming anymore. I started programming in 1987, right? With the Pascal, Basic, and all the stuff. I didn't really know that, but I do know that software is not that easy. Right? Somebody was telling me last night, that company was to build their own MRP, right? Material requirements planning. Nobody do that, right? Because it's complex, it's not easy, right? So focus on what you do best and adopt, embrace technology by working with partners, with suppliers, with collaborators, right? Don't do it all by yourself. By doing that, actually you can be more competitive. Quality control, in food, very, very important. How do you do quality control? I'm sure you have probably your lab, laboratory to test all the contents, the contaminants, and all those stuff. How do you control, how do you manage your laboratory? Is it by Excel, by paper? Do you have what is called as LIMS, Laboratory Information Management System, right? So that's something that you want to know if you never heard about that, right? But imagine again, if a potential customer come and audit and visit your plant, and if they see all these paper-based operations, manual transactions, tedious analog stuff, would they be impressed and be your customer, or they would say, I don't think I want to buy from this supplier? Think about it. Thank you.
Now we have William.
Yeah, I think basically again, Franklin already covered all the very important points there, but perhaps I would like to complement to it from my own personal experience as a recycling company who is now trying to go global, to be globally competitive. I think there are two things that have brought us so far until now. The first is our ability to be able to solve customers' problem and to add a value to them that is in one way unique. So like basically like a unique solution from us. So there are already a couple of projects that we have successfully finished, whereby we have, for example, replaced their virgin plastic consumption with post-consumer recycled material, so that it helped them to be able to fulfill their global ambition to achieve a certain level of recycling rate in their packaging. And we do that using the local Indonesian waste, although it's very, very much more challenging, and there are so much complexities around that. So that's the first thing. And secondly, will be surrounding the cost issue. So we must be very cost competitive. We must be able to offer our solution at a cost level that is still attractive to our customers. So we are making good profit, not a bad profit out of the business. And also given the current raw material price, which is very cheap, relatively cheap, for us recycling companies, we are facing difficulties not only to benchmark our price against our competitors, but we also must benchmark our price against the virgin price. And that is something that is beyond our control. So in order to be able to pass through these challenging times, we must be very cost efficient. We must very lean in our operation, and I think Mahindi and Frank are the experts on how we can achieve that cost efficiency by using the digitalization effort. So yeah, so for me, it's those the 2 points. How we can solve the customer's problem that is unique from us, and also being cost competitive.
Thank you very much, Wilson. Wilson is the Secretary General of the Indonesian Plastic Recycling.
against them. It's okay. Again, for me, for the recycling, again, I would like to challenge our mind. The technology is proven now. Definitely, I don't want to talk about the technology. I only want us to really thinking about the operational day-to-day of this technology. Our logistic cost is 18%. It was on the presentation yesterday. The 18% is the logistic of finished good from our factory to the customer. We did the supply chain job from one spot to the many spots. The recycling is to recollect the excess of it into the one factory. So I think it's very big challenge. Yeah?
Not clear.
Okay.
Your question, sorry, Ken.
Yeah.
Can you change the microphone? It's echoing.
I need to talk more?
Yeah.
Okay. Is it okay now? Thank you.
Yeah.
Okay. Again, thank you very much for now. I'm trying to be thinking our mind about the recycling. Okay. The technology of recycling is there. It's definitely proven. Yesterday we have a presentation that our logistic cost is 18%, which is the highest in Southeast Asia. What is so-called 18%? It's from our factory to the people, right? It's the total of logistic cost. Now recycling is from that point, the customer point, we collect it to the recycling centers. So I think we have to address that one, like, is it possible, is it financial okay to run the recycling, or maybe we need to then have to develop another technology that the recycling will be straight away on so many spots, small recycling. Thank you very much.
The question to me, right? Question to me, because I challenge you. Okay. The answer is straightforward. I believe that again, I said the regulation standardization is not working yet. But for the time being, that what we heard also, some of the presented yesterday, we have to make our own model. So in our model, in order to make it a collaboration, innovation, and acceleration, that one. Yeah, that means the ecosystem that we make. Yeah, later on you can add on. But for the time being, that is, I know the company that you're going to see later on, the factory, yeah, this afternoon. That is, they make a collaboration. Otherwise, it's not working. This company. This is regarding recycling of the PET bottle. This one, because the Coca-Cola will use that again as a part of that. So in order really to get the material, the feedstock for doing that, and this is with PET still with mechanical recycling. That is the point. Yeah. At present, we only have mechanical recycling that partly is still manageable in terms of cost and so on. Yeah. So that they can make, but to collect the feedstock, the waste. Yeah. That is the challenge in here in Indonesia. And that case, they have to work together. For example, with Bank Sampah, yeah, Waste Bank, and so on and so on. Yeah, that is the way that you have to do. Yeah, that is the model that you have to do itself. So your own ecosystem first, instead of national ecosystem. We dreaming that we will have a national ecosystem. That is very much important. I've been many years in Germany. In Germany, they have a dual system, Deutschland. So the system is working. You take the money is that every packaging is having a levy that you have to pay, but the money is not going into only to the government, but it's going to be to really develop the whole infrastructure that I'm talking about. So that is really a workable ecosystem already done. So that's why the highest rate of recycling in plastic in Germany, the highest in the world, is 70%.
spend hours talking about the economics in recycling, but to sum up in these few minutes, the short answer to your question is yes, it is still possible, given the tough challenge with transportation costs in Indonesia. Us recyclers in Indonesia perhaps are one of the highest payers, meaning that in order to get the plastic waste arriving in our factory floor, we have to pay one of the highest costs in the world. Because not only the transportation costs, you must also remember that the waste, the recyclable waste in Indonesia are recovered through informal sectors, waste pickers, junk shops, scavengers, etc. And the supply chain is not the most efficient one. It's not the most efficient one, and it's very convoluted. There are so many middlemen involved and so on. But yes, it's still possible, given the current condition with relatively minimum support from a regulation perspective. But I do agree with Mahendi's point that a multi-stakeholder cooperation is needed in order for us to be able to strive and recycle more. But yeah, given the current situation with high transportation costs, it's still possible.
Thank you. There's time for one more question, so if you have questions.
I have two thoughts that I do not understand. One is actually a thought, one is about curiosity about the high transportation cost of waste. I just wonder how much does it cost per metric ton? Do you have a number for metric ton point of view?
For the bale price?
Yeah, not the bale price, for the, you're talking about logistic cost to be the highest in the world, right?
No, the price we pay to get the bale right in our location. The price we pay for the bale.
Oh, what bill?
Yeah, so that includes the transportation, everything.
Oh, okay. Second question is, I'm curious that every time I go to meet people, people always say our margin is cutting, our margin is lowering down because we have to be more cost effective. But why are we not talking about value creations? Why cost? Cost is just one component of value creation. So I mean, give a this is just my idea, right? And second thing I want to share with manufacturer, that reducing cost in your manufacturing, it represents a very small amount of the whole business ecosystem. So don't look at your business from the factory perspective. You can from upstream all the way to downstream. You must analyze the whole ecosystem, and you can get a lot of benefit from it. Okay, thank you. So yeah, I need a quick answer. Why cost, not value?
Okay, so I don't know if your question is directly related to the plastic recycling industry or not, but looking from my point of view, from a recycling company, I do agree that we need to create unique value as well. We have, as a company, have successfully completed a project at which we are able to supply our PCR material at a price that's higher than the virgin resin. Yeah, that is thanks to the uniqueness of the solution that we provide. It's a PE case, not a PET case. PET is quite common where you see the recycling PCR higher than virgin, but for PE it's not something that's too common. However, there are very limited, let's say, buyers who are willing to pay this premium. So what we are able to offer is a 100% locally sourced waste that can fulfill the quality level that is suitable for FMCG packaging. And that is very challenging, and therefore it comes at a relatively high price tag. this period is, especially in Southeast Asia, is not that much. So given the current situation with the, I don't know, the gap is getting wider and wider with the low grocery price. So yeah, again, the competition in Indonesia is still very much reliant on how we can provide cost competitiveness.
If I can just add to the gentleman's point, the second point on cost reduction versus value creation, I think, in my opinion, both are needed. You do need to manage and reduce costs. I do agree that there's some level of cost reduction you can do. When I was working in MNC, you know, the Americans, the Europeans, they always say, oh, 7% cost reduction year over year, and we were all in the operation to say, yeah, this year I removed my fat, tomorrow I remove my muscle, right? The year after that is always skeleton, where to be used, right? So, so there are some limitations for cost reductions, but having said that, I think you would agree that it is important. It is not something that we can ignore, and we have to find innovative ways how to reduce costs. And this is where I think the part is missing, right? How do we use technology to reduce costs? How do we do better? How do we be more leaner? How do we be more productive, you know, producing or churning more things with the same resources, right? Resources being the machines, the people, you know, the materials, and so on and so forth. On value creation, this is interesting, and I remember there was one minister that a few years ago says that Indonesia has multitude of problems, but with these problems come a multitude of opportunities, right? And I think this is where I think with the problems that we have, there are a lot of opportunities to create value, right? And a few days ago in Singapore, before flying to Jakarta, I was actually discussing with some academics and some research institutions, and we were discussing about how we can create new business opportunities, how we can create what's called a servitization. Servitization is basically, you're not only selling product, but you are selling service. What are the service we can do, you can do, instead of just product, right? You're selling service. Well, what does it mean? Take example, the software company, let's say Microsoft. They sold the CD last time, right? The CD contained their Microsoft Office, blah, 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 and those things. Now the internet, no, it's all on the cloud. Okay, no more CD, right? You're buying my software if you're talking about Office 365, for example, you are buying basically, you're renting my software. Every year you pay my service, right? To give you the best word processor, PowerPoint, and all those stuff, right? So that is going towards service. And if you look into the successful companies, technology companies nowadays, you know, you name it, right? Whether it's Google, Facebook, Alibaba, whatever it is, right? They are selling service to all of us. So I think, yes, let's not restrict ourselves with what you have as what you need to sell, but think about what are the values you can create, you can innovate, you can bring to the table, bring to the market to resolve all the problems that are existing in Indonesia and globally. Yeah, that's my point.
Maybe I don't know, not so much time. I will answer you this straightforward. Why not value? Why is the cost? Straightforward. Value is a matter of perception. So we are talking here, the 2 days, It's a commodity. A commodity. So this is everyone working there, yeah? So the value is based on the supply and demand, okay? But if a value that really a premium value, that is a matter of perception. Why is, for example, that the bag of Louis Vuitton or Hermes, why is so expensive, but maybe in Bali as well, yeah? Maybe, yeah? Maybe. So, but why is so high, the value, yeah? It's a matter of perception, the media, the build-up, the brand image, yeah? It's a matter of premium product, but we are talking about commodity. So that's why cost is very much important.
Okay, thank you very much. So let's all give a round of applause for all our families. Thank you very much, Frankie, Wilson, and Frankie, and we hope to have you back again. Now, we come to the last part of our, yes, okay. So we would like to have Pat Frankie to get the lucky winner or the lucky draw. Okay, thank you. So we have two prizes, but before that, may we ask you to please answer our feedback. Yes, we need to answer first our feedback form before we start with the lucky draw. Where is the QR code is on the conference folder. Okay, the QR code is on the conference folder.
Yeah, the one that's luckily that I took is Miss Fanny Tallinn. Mrs. or Miss Fanny Tallinn from Tamil Park. I think I met her yesterday. From Tamil Park. She's not coming. Making me up. The next is Anthony Fernando from AEL. You know what is that? Global Initiative, Global Mega Trading. Is also not here? I suppose. Yesterday. Okay. It's from a sponsor. Well, no. There's Giovanni from Panera. Wilson, is that no? It's not coming? It's your guy, huh? Too bad. Huh? Okay, that's not you. Oh, could be also not. Daisy is not coming? Ampersand. Also not coming. Too many are coming today. It's also not. Huh? This is Stalinga. Yesterday also I met her. I think Aris Setiawan. Recycling company. Aris. No. Recycling machine.